All right. Hello, everybody. So looks like we're getting real close to the end of the semester now. Today's lecture finishes out week 7 in an 8-week course. These things do go pretty quick. So one of the topics in the textbook this week was the e-commerce. And for those of a couple people have already turned in that homework, you saw it's pretty much just on the website, that yoga website. You're just adding a button, an add to cart button. And when we looked at embedding pre-made things last week, which by the way, when I made that video, something in there, when I posted it on YouTube, because that's where I save all the videos for like long-term saving, that video won't play on YouTube. Like I can see it, but it says there's copyrighted material in there. Like, whoops, I forgot the bots would check that. So for some reason that video won't play on YouTube, but it is posted on Canvas if you didn't see that. But on that day, we looked at PayPal, which is just one of many options available. It's probably the biggest one. And we saw that to get those cart buttons and the checkouts and all that stuff, it's a pre-made thing. They give us the code and we just copy and paste that into our page. And that's pretty much how e-commerce is. Beyond that, it gets into marketing. And that is a huge field in and of itself, that catching people's interest and keeping people's interest, and marketing is kind of a big deal. But basically, as far as coding goes, it's a lot of copy and paste stuff. Those things are already made. They're ready for us. All we do is just go grab the code from the service we like and paste that into our page. And then the end user has a button that says add to cart, and all of that's handled. So that's fairly straightforward as far as using that. So I wanted to take some time and look at a couple other some other aspects, related things that related things about markup languages. And then at the end, I have a couple more of those useful tags that didn't really fit anywhere. But again, it's probably going to be kind of a short lecture. That way there's plenty of time to work on any homework that needs got up, or really at this point, the project. Oh, there's Isaac. Let him in, put his name on the list. Hello, Isaac. We were just getting started here. So I want to look at things that are related to what we've been studying. Well, the second set of notes is definitely a very big thing on web pages. But so this semester we've been learning HTML, hypertext markup language, the markup language standard used on websites. But not everyone required to take this course is planning to do web-based work. And part of the reason for learning that everybody has to learn HTML, even if they're not planning on doing any web stuff, is to get a good introduction to markup languages for other software development purposes. So with our HTML tags, most of us have been looking at markup languages as a data transfer thing. Right? We have the text and images, and we wrap those in tags and use that to transfer that text-based data or the graphic-based data to some client computer to be displayed. And the tags, the nice thing about tags is they give a clear start and end point. So whatever tag we have, I'll just write T. I'll make one up here. We have the opening tag, whatever all our data is, and then the closing tag. So when we look at, when we write this up, it seems like a little bit extra, but there's kind of a start and end point are clearly marked, right? So it's like we have our start tag, and then our data, which is just Unicode. Can I write this out? So A is 97, 98, 99, 100, which is, well, we have all that binary code, right? So I'll just write the decimals. So this is really ASCII, would really be ASCII code, a whole bunch of binary, but I'm not going to write the word data out in binary. It wouldn't take too much though, because that's what, 100, 97, whatever T is. 97 plus 20 is 117. And then ASCII code 97 again, which Unicode is just the extension of ASCII code. ASCII, so the first 256 characters in Unicode are ASCII code, so they kind of blend together. And then we have that endpoint clearly marked. And this is why this makes a good transfer one, because it's very, very efficient as far as processing goes. The computer doesn't have to figure out where the start or the end is. We don't have to add in any filler bits to make it a certain size and fit in registers or anything like that. Just whatever the data is, we just put a clear indication where the start and end is. Which makes it kind of ideal for a processor. So when we need to do some optimization, markup languages are very useful for that. So probably not, so drifting away from HTML now, because that's not the one that we would normally use some different ones. A similar one, though it's not standardized, is XML. That's one that's very, very commonly used. And it's not standardized. We completely make up our tag names every time, but the computer will recognize those tags as a start and end point of all the data we send. And if we're completely making up our tag names every time, we also have to make up our parsers every time, but that's really easy. That's just a bunch of if-else structures, bunch of branches. We just look for the tags we know are going to be there in our data. So have any XML things handy? I'm going to share my screen and pull up something in XML. So a common one would be like an Rssv. So let me see if I can find one, a useful one to work with. I was actually expecting to get something. That stands for really simple syndication. It's a way of sending data. Oh wait, if Bobby server is still up, I think I have some stuff on there. Whenever I teach the Android class, I would always put this in. So this is the old server we use. They've stopped support for it. It hasn't completely crashed yet. Yeah, so like Rss Testing. So this is just one from a class example a couple years ago, but you'll recognize this kind of a markup language. A markup language like HTML, we still have these tags. So RSS is really simple syndication. It's a quick way of sending data, and it's pretty much the standard form to do it in XML. There are two standard forms. I'm going to talk about that in a second. But we have the start and end tags for everything. So here's some stuff just about the channel. And as I'm sending URLs and links and some text data, and then we pick this up, sort through those tags because that makes it easy for the compute processor to work with. And then we just display this data is the basic idea there. For data transfer, using those for data transfer. I'm glad that still worked. I probably should have grabbed an example to put there. I better put that in these notes before I use them next time I teach the class. And it's very efficient for the processor. We don't worry about that workload on the processor as much as we used to, right? Back in the 80s, 90s, if any of y'all remember that, back in those days, computers couldn't do much. But anymore, the CPUs have gotten really big. We don't worry about the workload that we pass on to it as much. So using XML to transfer data has kind of slacked off. It's still very common, but it's also very, very common to use JSON. That's JavaScript object notation, which it's easier for the programmer. So JSON is less for the programmer, more for the CPU, and XML is more work for the programmer, less work for the CPU. So at times, we might still have to worry about efficiency. Computers have gotten faster, but there's still no shortage of things we can do to bog them down. Can't remember if I've talked about it in this class a few years ago on my way through school in a class on a language called R. The data set we used in that class was the cholesterol data. And I say the cholesterol data because it was pretty much all of it. It was downloaded from the CDC. All identifiable information is removed. So like names and social security numbers are taken out, so you can't tell what's what, but it would have the date of birth, the person's weight, their HDL, LDL, and their height. And there might have been one other thing, so we could calculate BMI from it, calculate body mass index, and where applicable, had the date of death. So it was all the cholesterol data collected in America, not just from the people that are alive, but all of it the doctors have collected. And some people might have been in there more than once, people that have passed away, as well as people that are living. There's a huge data set. And the reason we use that is to bring in the efficiency issues, because something like that, you have to start worrying about efficiency. Right? If there's 500,000 data points to go through, it's going to slow down the processing some. But we still have big, huge data sets like that where we might need to buy back efficiency, or other times when we might need to buy it back. I'll talk about some of that here in just a second. Yeah, I don't really have a whole lot on the notes about that, but with data transfer, it's usually mostly JSON or XML anymore. I'll have something else I know I can share a screen with a good point on this, and we kind of have to make a choice. Right? Like I said, the JavaScript object notation, JSON, is less work for the programmer, but more work for the CPU. So if there's huge workloads, it's not the most efficient thing. Whereas XML is a little more work for the programmer. Not really, because we can write, we usually write scripts that take care of all the tags for us. We'll just type up the data, and then we'll have a script ready to add those tags onto the data, so we don't have to sit there and manually type them every time. Which I think I have one here on my computer I can pull up real quick. Might as well look at some examples like that. This was a project I was working on not too long ago. Like this, yes. Somewhere in here. Oh, not there. Well, I can't remember where it's at on this now. It definitely wasn't interface stuff. Gotta be back here somewhere. Oh, there it is. I don't know why I just tried to run that. Run that. Open it. And this one I had to do a little bit more in because it was in Python. I didn't like the pre-built loader. That's why I decided to pull this one up before the one I was getting to over there. But yeah, you can see we can just write a script that adds all these tags in. Just concatenates strings together and adds a bunch of line breaks and tabs and those tags in as we need them. And that way we only have to write those tags once and then just have the computer write them for us. So it's not really that much more work. But what I wanted to pull up here is usually when I'm setting things up for data transfer, when I do the database thing, this will have it. These are just a few projects I've been working on recently. When I do like the database retrieval, I'll go ahead and set the code up to do both ways. And that way, I need something transmit. There's transmit. That way, whenever it comes time to actually use it, then I can decide whether I want JSON or XML or some other format on the fly. Because it doesn't take much to set it up. So you saw in that last one, I was just, I'd typed that stuff in myself, and it was only a couple lines of code to do that. But it's also pre-built. So usually we can just call methods like append, set up a root element and append a child. And then we end up with, that's treated as a tree as well, which is another big efficiency. The processor has the start and end point for all the data and organizes it into a tree structure, which makes it very quickly, the computer can very quickly get to any particular element in that. But it doesn't take much to go ahead and set that up for either XML, even less to encode it as JSON. Actually, something in CSV or something. But I'll go ahead and set all that up off the bat. You can see, probably can't follow quite all this code, but there's a database query. I'm going to run a query on the database to grab a bunch of this stuff. And then the results from that query, I just set up a short if-else structure to either create an XML format or a JSON format. And that way, whatever project that data ends up being used on, it's already ready to go. And it's a whole lot easier to do it at the beginning than to come back and try to adjust something that's already finished because you need the other format. It doesn't take much to go ahead and set them both up. But the data transfer isn't the only issue. The only time we might need to improve efficiency is for those who've had a little bit more software development courses, you've probably encountered object-oriented programming. Most software these days is developed with object-oriented programming, which is something that is good for the human, but bad for the machine. It comes with tons and tons and tons of overhead. We won't get into it in this class, but whenever I'm giving a lecture on that, I always start the lecture with the tree of life picture that you've probably seen from a biology class or something biology related. Most people have encountered that tree of life where it just keeps getting wider and more specific as we go down. And I'll draw a quick version of that on the board, and then I'll model out an object-oriented program next to it, and you'll see it's the same picture. So it's the way humans naturally do things, which is very, very different from the way machines naturally do things. It was invented back in the 60s, but it was the mid-1980s before even really nice computers, really high-end computers could handle it, because there's so many losses of efficiency. But the programmers can do programmers can do lots and lots more with object-oriented stuff. So we really typically don't mind passing work onto a machine. That's what the machines are for. So most stuff's developed in object-oriented programming, so it's kind of inefficient. And if we start to do big things that need a lot of, that are going to take a lot of processing, it's nice to buy back some of those inefficiencies when we can. And markup languages are ideal for a machine, for the CPU. They're ideal for a machine. So that's a great place where we can buy back inefficiencies. In particular, if we have non-dynamic things on the program that aren't going to be changing constantly, we can use markup languages to buy back the inefficiencies we would lose using object-oriented programming elsewhere, which is one thing with software development that this class is also good practice for. We mix and match our languages. We typically don't sit down and write an entire piece of software in one language. We mix and match them and pull and try to optimize it. Use the best qualities from each of the different languages and put together an optimization so that it runs very efficiently and stuff. So a couple common ones, in Java, we use XML, C#. Those are two of the most popular languages anymore. In C# we use one called XAML, which is, it's spelled XAMML, but it has that ML at the end. So it's another markup language, and it's almost identical to XML. It's just a bit more standardized because it comes from Microsoft. So they want you to use the tag names and attributes that Microsoft already set up, and not, instead of creating your own. But they're used essentially the same. I guess I have an example of that I could probably pull up here somewhere. At least have some Java stuff. Although the internet, as usual, is not in a hurry with the Zoom call running. Let's see. I think I have something on my Drive account. Oh, pictures are in the way. Cool stuff. And then there's, see, 4 short examples of HTML stuff for after we talk about this. I stuck them on there so I can pull them up on the tablet. That's a lot easier than writing it all down. Okay, this is taking a long time. Oh, there it goes. When did I last teach Java? Fall 2019. I think I have some in here. Yeah, there's one. Oh, actually, there's another one on that project. I'll come back up to that one. Probably here, yeah. There it is, beanies. One of the things with Java programming, it's really more of a concept called beans, but we often do that with beans. Sometimes our objects are pretty much just data things that we kind of keep the data, a place to store the data, and when we're going to process it, or so that we can process that data later and keep it all nicely organized and things like that. And beans is kind of a standard where we follow naming conventions and certain access levels so that everything's the same. It gives us more flexibility when you get to, most of that's a little beyond the scope of this class, but it gives us more power of what we can do with programming when we know that everybody programs their stuff the same way. But along with that, a lot of times our objects are just holding data to be processed later, which means that if they sit there if we just create the object and it's holding data to be processed later, we can't delete it. So it's going to sit there in memory and waste a bunch of space on RAM, just sitting there that could be used for something else, right? Most computers run more than one piece of software at a time. So even if it's not on our software, you know, some other piece of software that's running at the same time in the background could be using that RAM that's being wasted. So one solution around that is what's called factories, where we basically create disposable objects. All our objects are one-time use things and then get deleted immediately. But they're a little difficult to work with. So another common one is to take our objects and put them into XML files. So this was a class example. It was just using little data points about animals to keep up with it. But you'll see those markup tags like what we're used to seeing this semester from HTML. So XML says XML file, how it's encoded. And then we have our start and stop tags for all our data. So here we have there's an integer piece of data to it, a string piece of data, a floating point number piece of data, double precision floating point. But we can keep our data in this form, which doesn't burn through the processor quite so rapidly. And I guess I'll open the source files. It's a Maven project. So I have a whole bunch of files to click through here. Eventually I'll get through all these folders and get down to the source file and see the thing I wanted to point at. There it is. It's probably in this one. And here in the code, like we create these objects, and then instead of keeping them in memory the entire time, we can just turn them into that XML file. And then it gets deleted from memory. It's not sitting there wasting RAM, and retrieve it from memory, which this probably isn't a good example because this was a stripped down example for a class. So all we did was turn it into an XML file, let garbage collection delete it, and then bring it right back. But in bigger situations, that sort of thing can be very helpful. You can see there's not really a whole lot to doing that in the code. We have this built-in encoder thing, an encoder and a decoder that's already built for us, so we just ask for that code. Those going into software development, you'll see there's a whole lot of that. There's a whole lot of pre-built code we can use. And then there's some other stuff. I go up a couple levels, back up to this. Should have a manifest. Yes. Also, when we put a big piece of software together, there's a lot of files. So it usually includes something called a manifest, which is kind of just like a traditional ship's manifest, you know, that list of everything on the ship and why it's there. The list of everything in the software and every file and resource that's needed for the software and what it's for. And XML is a very common way to do that as well. We can see there's those tags. If I come back up to this same folder, or in Android devices, I have examples here. Yeah. That's another very common one where we tend to do a lot of stuff in XML. Anything that doesn't have to be done, so like a manifest file, again, that's just a list of everything there. You can see there's this big tag talking about that angle bracket indicating the start tag for an application and everything that's going to be on that application. And then open and closing. Some of that probably looks confusing, but you can recognize that as tags from a markup language now. And again, we have this starting with XML, it's encoded in Unicode, which that's the big efficiency right there. And it throws people off at first because whenever we write this stuff, it seems like we're writing so much more than when we do object-oriented things. But the object-oriented stuff has to be processed, so there's a lot of overhead that comes with it. Whereas an XML file, extensible markup language, is just straight Unicode. We see the entire thing. So there's not a lot of overhead hiding in the background to mess anything up. But Android, we do that a lot. What's that? That's going to be under resources. So all of these folders are just filled with XML files. I'll pull out some here. Okay, so this is a user interface, which is a lot like what we were doing on web pages, right? We set up the tags and then position them around the screen and stuff to create a nice user interface. But again, that is non-dynamic. It doesn't need to change constantly, so we don't need all the overhead that comes with object-oriented programming to do that. So we can move that stuff into a markup language and buy back the efficiencies that we lose with object-oriented stuff. Let's see, do I have anything else on the notes? Yeah, that looks like most of it. I have it summed up nicely in the line I have here. Good for human equals bad for machine, and vice versa. Good for machine equals bad for human. So there's sort of a trade-off, and markup languages are often used in that trade-off because it gives us a human readable form that is great for the machine. That's another thing. It's well, I pulled up all those XML files there, and you could read them, right? It was all, might not understand what every bit of it means at this point, but you recognize it's a markup language, and it's all text-based, the same thing we write English in. So it's human readable and good for the machine. So it's a great way to buy back efficiencies in most of our in software development, which again isn't as big a deal as it once was. Back in the 70s, 80s, 90s, that was critical. Then it's kind of, the steady increase and improvements in technology have gone down, and we don't even worry about that at all anymore. That's why Python is the most popular language in the world right now. And I mentioned Java and C# with Java with XML and C# with YAML to work with efficiencies. And Python is definitely the most popular language in the world, and I didn't mention that because it is, and Python is entirely to be easy for the human. It's terribly inefficient. But again, we usually, if the machine can handle it, we don't mind adding to the machine's workload. It'll sit there and do it forever with no complaints. So that's a big part of the reason why everybody has to take this class, just introducing markup languages, because those are incredibly useful in the long run with software development. So even if you're not going to do anything with websites ever again after this class, you'll see that. And mixing languages, right? We've been looking at HTML and CSS the whole time and intermingling those. And that's a good example of we typically don't work in the same language the whole time. We mix and match what's best for them. Have some odds and ends for CSS next week that we'll see where we could put content onto the web page from the CSS thing. We could write our words into onto the page from the style sheet itself. We'll see counters. I might do some math in CSS. I did that once and it's very confusing. One of the things on the list today is do math in the HTML. Any method we have we can use to give a machine instructions, we can use to give a machine any instruction that a machine can be given. However, it is completely unfeasible at times. We're going to do some simple math in HTML near the end of the class lecture today, and you'll see that it is not a feasible thing. You would not want to do more than add like two numbers together. That's probably what we'll do. Add two numbers. We might multiply something. Just a simple example. And just because we can doesn't mean it's feasible to do so. And similar thing in CSS. We could put all the words onto the web page from our style sheet using the content tag. We could do some math and use set up incrementers and accumulators and do some basic math and do all kinds of stuff from the style sheet, but it's not feasible in CSS. CSS is optimal for laying things out, for layouts and colors and style stuff. That's why we use it for that and not for doing a lot of complex math. So I'll probably throw it on the list for VODs and ends next week just so that you can see it can be done.
So it's sort of like trying to mow your yard with a weed whacker. You could, yes, but you wouldn't want to.
It's possible, yeah.
Been there, tried that once.
Yeah, I've done that a few times. When the lawnmower's broke, you don't have a choice. But it's that's a great analogy, Joe. Thank you. And yeah, that's why everybody has to take this class, even if you're not going to be doing website stuff, just to see the markup languages and get familiar with that, because you probably will be using those somewhere in software development. But XML is just like HTML. The big thing to remember is it's not standardized. So you make up the tag names every time. You make up the tag names, the attributes, and all of that in there.
So how does the computer know what to do if we made it up?
Oh, we have to write the code. Then we write a big if-else block. If, else if, else if, else if, else if, for every tag that we made up. Does that make sense? So I'll use some HTML examples here. So
okay, cool.
Some of the tags we've seen, we write those in there, and then we just put a block together. So if I'm going to write string str, that string that's coming through, if that thing passing through the computer is equal to a p tag, then do paragraph stuff. Else, if that string of Unicode passing through the processor is equal to, I should put two equal signs, not assigned, that string is equal to a div tag, then we're going to probably do layout stuff. Does that make sense, Joe? We can just keep building that if-else structure.
Okay, so basically that whole structure would cover any of the tags you made up.
Mm-hmm. And this is what the browser does. This is already written in the browser. If you view the source code for a browser, that's what you would see, because HTML is the standard, so that's what that's what's standardized about it. Anybody that wants to make a browser has to address all of those tags. Else if string equals or is equal to an H1 tag, make text big.
Okay, so that's all in the background that we don't see because we just wrote the code.
Yes, all this is in the browser. So if you ever write a browser, you'll need to.
Don't think so. Not anytime soon.
And if we're using XML just to buy back efficiencies, we do this. Because this is what computers are best at. that comparison.
Yeah.
Actually, everything else, all the math that they do, all the data storage is all built off of the computers can make a
okay, so
comparison.
to a certain extent, then most browsers are using a common set of those statements because HTML is pretty standardized.
Yes, yes, and it's actually very common because Edge just dropped theirs and they picked up Chromium, which is the engine that Chrome runs on. So it's
when you say the engine, when you say the engine, that you mean all this stuff, all this code stuff.
Yeah.
Because once somebody's created all that stuff for the standardized language, anybody can use it. I mean, as long as they have the right to.
Yes, and that's what's different with the browsers. They have different engines. I have to step behind the computer for a second and close this window. Yeah, they have different engines, so they set up different ways to parse through those HTML tags.
So people do try to reinvent the wheel.
Yes, because it's not perfect. Right?
Well, no, but it's so they're trying to. Somebody else tries to make a more efficient one or more inclusive one, or maybe one that handles a few of the extra tags that aren't standardized.
Yeah, exactly.
So is that where we end up with some of these things? Well, this isn't standard HTML5. But most browsers will handle it because the engine has that as part of the if-else structure.
Yes, exactly. And not just somebody else, because like when was last? At some point recently, Google Chrome updated on you, right? So they made improvements to what they already had.
Probably, and I might not have even noticed it.
Yeah, usually we don't notice when Google Chrome updates. They don't tell us; they just do it.
No, it's not like Zwift where you have to sit there and let it all upload and hope that the patches work right. Yeah, I mean most of the other stuff's pretty transparent. Like bang bang is done. Oh, by the way, we're assuming you want to upgrade this.
Yeah. Like the only one I've noticed this year is if you have a Samsung phone, you would have noticed Google Chrome is very different on a Samsung now. It's a nice feature. You can view all your tabs at once as like different icons and move them around and stuff. But usually we don't notice that. But yeah, all of that's going on in the background. So if we know what all those tags are, we can write them in our code. Because usually we don't have that much either, right? It's not like we're going to write one of these big branch structures for all of the HTML language. You know, we might have 12, at most a dozen things that we're using. So it's not very much to go through and write it. Uh-oh, Joe disappeared on us. Hopefully that makes sense as you progress further, because some of that might come up still. I better pull my phone out because he may send a text if his internet went down or something. Well, that'll be fine. But yeah, that's just kind of a preview of something you'll see later. I wanted to make sure and talk about that somewhere. Let's see. My next set of notes, I was thinking it's probably going to take half an hour, 45 minutes again. Maybe do that after the break, and we'll look at something else here real quick, HTML-wise. I have a couple tags on the list here. One thing we haven't seen yet is image maps. And sometimes they're kind of frowned on. They're definitely not the fastest way to do things. But I'm going to do a quick HTML example because the next note packet I have here will take us beyond the break. So I'll wait till after the break to start that. And hopefully Joe will be able to rejoin us. Oh, there he is. Hello, Joe. I figured you'd be back before too long.
Yeah, I don't know what happened. I was hollering at my wife, telling her I think something's dead, and she went and checked, and everything's right. So I don't know what the heck happened.
You're in New Albany, right?
Yeah.
There's that cable upgrade. I keep getting stuck behind it, so maybe they had to flip the switch for 10 seconds while they switched to the new, faster cables.
Must be.
I know I keep getting stuck behind that every time I go to New Albany. There's like construction somewhere where they're running fiber or something.
I don't know.
Okay, but yeah, so my next set of notes would have to be split up, so I'm going to wait till after the break to start that one and just look at one of these tags. So I'm going to go ahead and start a web page, just to kind of look at an issue that we might encounter at some point. So all that stuff we've seen many, many times this semester. Go ahead and set up our tags. And hopefully all that stuff made sense. That was just kind of, that stuff earlier was just sort of an introduction of something you will see, and non-web people when you'll see this again. Oh, looks like Joe left again. I guess his internet's just not going to cooperate. That happens sometimes, but that's why these videos are on here. Hopefully he's looking at the clock and noticing what time that happens, so he can jump right to the spot in the video. Okay, so I was setting up a web page here. I'll call this map, map.html. So maybe we don't want a bunch of words or something on our home page. We want a nicer looking picture. So I'm gonna go over here to the internet and download a nice picture of a beach. Beach picture. This one will work. Hey Joe, is it coming and going?
Yeah.
Oh, as always, it's being recorded, so it looked like that started on you about 45 minutes into the video. So
yeah.
Nothing really much going on here. I started the HTML document.
Okay.
And I'm downloading a picture of a beach. So I found this nice one that has a lot of different things on it.
Okay.
Nothing too fancy here. Yeah, because my next set of notes will probably would take us past the break. So I'm gonna go ahead and do one of these tags from the end of the thing. So I have this thing, beach.jpg. With some chairs and palm trees. Looks like a really nice place to be sitting on a day like this. So maybe that's the only thing I really want to show on my homepage for some site, right? Just that page, and then go into that. We can put that as a background and put some buttons on top of it. But there's another alternative we could do as well. So source equals beach.jpg. Put that over there. That's not what I meant to click. And then I'll go open this page up. So open this maps.html page. Now the home page is just kind of a nice picture of a beach, right? Come in, it seems very inviting place to get things. And we could use that as a background image and put some buttons over it, maybe even make the buttons hidden. But we could also turn this image itself into a bunch of buttons we can click on. So to do that, we have to set up some clickable areas. And this is why I had examples pulled up on my tablet, so I should probably go ahead and open those. That way I don't have to. But for example, we could set it up so that clicking this umbrella looking thing takes us to some other page on the site, or clicking on the chair or the little margarita here, clicking on the ocean, and just have these different clickable spots around here. Oh, actually, apparently I didn't set this one up in my example, so I'll just have to set this up. So what we do is we can define areas of the tag to click on. First off, we kind of need to know where those areas are. So I'll do that, and let's go list out where our areas are. So I'm going to set a comment up here just to make some notes about the spots in that image I would like to click. And I guess we'll probably open this with any graphic software. Opening it with Paint will show the areas. Open with Microsoft Paint. There are much better things to open it with and check, but you'll see down here in the lower left-hand corner, as the mouse moves around, we get the X and Y coordinates. So to say clicking on that umbrella is like a triangle from 5 to 48. So let's see, I'm gonna make notes. Umbrella, triangle from 5 to 48 to 559 to 28. And then the top of the triangle up at about 282, 120. Does that make sense where I got those numbers? Just the three corners of a triangle, the XY coordinates from the graphics. And it gives us a way to mark that spot off. Or a similar thing, we do maybe a big circle over here somewhere. 937, 337. Just looking at those coordinates down in the lower left corner. It's about 937. I forgot where I was. So 984, 334. Ocean. I'll just do that as a circle with a center at 984, 334, and a radius. So we need for a circle is just the center and how big, what's the radius of the circle. So somewhere around there, maybe 100 pixels wide. Maybe 120, probably go a little bit bigger. And what's something, maybe a square thing. I'll do a little square around this margarita glass. 404, 526. And then a square or a rectangle, all we need is two corners to define it, right? If we know the top left corner XY spot, XY coordinates, and the bottom right, then we know how wide and how tall that rectangle is. So just enough to define the basic geometry on these things. So the bottom of that's 418, 546. So does it make sense how I grabbed those coordinates? Hopefully everybody's had a little bit of geometry, so that's it. Hopefully making some sense. Do I have anything else in the notes here? What was this? Okay, sorry. I was trying to open my example, but it didn't want to cooperate for opening. There it goes. So whenever we have a picture like this, there's the browser. Back in the browser, instead of putting words and buttons all over the place, we can just turn those into buttons based off of some primitive basic shapes. And to do that, we set up a map tag and some sort of, it does need some sort of name. I'll just call it beach pick for a name. That's just a requirement for a name. We'll see why in a moment. And I always put it above the image. That's not absolutely necessary. But in the image, we also need this attribute use map. And then that has to refer to the name that we gave it. But it's going to look like an ID because we use the hashtag beachpick. So we give it a name, but it kind of looks like we're referring to it as an ID. That's just whoever set that up. This was way before this stuff was standardized in HTML5. So they probably just picked that symbol arbitrarily. That'll give us a way to turn that image into a button map, basically. We can put a bunch of buttons on there. So to do that inside the map, we set up an area tag. So area, and then we need a couple things about it. So like what sort of shape are we doing? Which is pretty much a rectangle, circle, or a polygon are our main three options. A polygon just means lots of sides, but since we'll be entering XY coordinates, it might be better to think of polygon as lots of corners, and then the sides just automatically fill in. So we say, what area is the shape? So it's like a rectangle. And then what are the coordinates for it? And a rectangle, we can identify from 4 coordinates. If we know the top left corner and the bottom right, then the X coordinates tell us how wide it is, and the Y coordinates tell us how tall it is. So we use those 2 corners, 404, 526, and 418, 546. I think this uses the corners. If this makes a really, really big box, we'll come back. One thing about programming is sometimes we put in the 2 corners, and some programming languages want the first corner and then height and width. But if I'm remembering correctly, area wants the 2 corners themselves. And then we just need something for that button to go to. I'll go to Ivy Learn. Oh, I guess I need this stuff. So if we click on that margarita glass, it should go to our Ivy Learn site now. And notice that whenever I hover over that, we get the cursor change. It changed into the finger. And if you can see it down in the bottom of my screen, it's got that little hint text showing up saying where that's going to go. So when I click on it, yeah, it jumped over to at least the sign-in page for Ivy Learn. Just reopen this. I'll go ahead and sign in that way we can use that link and see that it works. There's also a way to give it a name, which can be useful. That is something we saw the other day. So it's not actually part of the map. But, well, I'll do that in a moment. I'll put the other shapes in here. Along with that, we could also set up an area tag. The shape equals a circle and the coordinates. And a circle requires even less coordinates, right? Because a circle is just the center point and a radius, and that defines the whole circle. And grab those earlier from the picture. So 984, 334. And a radius of 120 pixels. And then again, it needs some place to go. This time I'll go to the other school site. my.ivtech.edu. And kind of finish that out. We're going to save it and reload the page. You see, moving the mouse around, we still have that normal arrow. Then over where we put that rectangle is a button now we can click on. And somewhere over here on the ocean is another button we can click on, kind of highlighted there at the end, which provides us a link to jump over to the My Ivy page. Which I guess is sort of an arbitrary thing. Loading really slowly too. Can I go back? Okay, yeah. Maybe a better site to go to would maybe something more useful. I'll just pull up the Wikipedia sites for like ocean. Something a little bit meaningful there, I guess. So I'll copy that and put that in the code here. So when we click on the ocean, we'll get a description of the ocean, or yeah, I'll just leave the other one like it is. What's the other one? Umbrella. I should probably put in Wikipedia because I have a feeling there's lots and lots of companies with umbrella in their name. Or songs. So I'll just look at the basic, what is an umbrella? For a third link here, which is going to be a polygon. So that's our three basic shapes are either a rectangle or a circle, which are very straightforward, or we need a polygon, which has lots and lots of sides by definition, but we're entering coordinates. So when we're programming, it makes more sense to think of it as lots of corners. which it's a triangle, so we just need 3 corners, and we just list them out X, Y, X1, X, Y, X, Y, X, Y. So like X1, Y1 is 5, 248. And then our X2, Y2 would be 559, 228. And our X3, Y3 is 282, 120. And however many corners we have, right? If we have a shape with 100 different corners on it, we just list all those corners out and then someplace for it to go. Href will be.
Now, of course, this is assuming that everything is full size and everything. What happens if I resize my browser?
That goes with the image. So if the image size, that's the coordinates on the original image.
Aha.
So if you change your image size, you need the coordinates from the original.
Okay.
And it will adjust.
Coordinates are for the original.
Yeah. Yeah, that's why I was just open it up in Paint. And then as we move our mouse around, we can see those XY coordinates. That's a really quick, easy way to grab them with something you probably have there. So now our umbrella is a button. So we can click on that little triangle and get the Wikipedia page describing what an umbrella is. Which looks like a surprisingly long page because apparently every culture seems to have a history about umbrellas and parasols. I guess it kind of makes sense. We want to get away from the sun. Somewhere in there, there's probably the Cancun type umbrella like this.
So this is how those sites that you click on something and it tells you about it. That's how they're written.
Mm-hmm. Yeah.
Sort of.
So that's a good way to do it.
And in some cases, instead of going to an external reference, it'll go to some other little file within everything to give you more information about it.
Exactly. What I was getting ready to show would help with that. Anytime a picture would make more sense. So one place I've used these a lot, or somewhat a lot, is for one of my hobbies is programming little educational games. Not super fun games, but more fun than a math quiz, the multiple choice math quiz or something. Little educational games. And for a controller on touch screens, I've used an image map. I just took a picture of a controller and put it on there so that on the touch screen, you could just touch the pictures of the controller. Not always, because that's for games where speed doesn't matter, where it's essentially a multiple choice quiz and just an animation plays when you hit the right button or something. So not in something where speed matters, but they're used for that. The reason they're not highly promoted is they've also been used nefariously over the years. Like, say some big corporation has some information that it would be illegal not to share with their shareholders, not to tell their shareholders about. But the sort of information that they don't necessarily want to go advertising to their shareholders. So they could do something like, if the company logo was like a redheaded girl with ponytails, they could turn the ponytail on that logo into an image map. And then, like, if you click on one of her ponytails, you go to an alternative homepage that has a link to that shareholder information that it would be illegal not to share. And then that big corporation can be like, well, the information was there on the website. If the stockbrokers didn't read it, that's not on the corporation. So image maps have also been used for things like that. And it's, so that I think that's why it kind of cuts the promotion. What you pointed out, it's a great example of it, Joe. And along that is, well, when I'm moving around, there's not really much going on here, right? we can see the icon change. So we know there's a button there. And down in the bottom, we get the hover thing. That thing we looked at Monday, I like to use that on image maps to get a little abbreviation. So like, or I get a little hover text. So that abbreviation tag, and put the title equals umbrella, and then wrap the area in an abbreviation tag, like we saw the other day. And that way, when we go hover over it, we should get some hover text. Hover text wasn't pulling up. Why is that not pulling up? Did I put it on the wrong one? Oh, I put it on the wrong one. That's why it's not. What is that? That's margarita. And then umbrella is this one. That confused me for a second. I was like, I know that should work. Go to the end and close that abbreviation tag. So we wrap the spot on the image map in that abbreviation tag, which includes hover text. And that way, when we hover over it, we get a little pop-up, which would work great for what you were mentioning, Joe, right? When you hover over that, you get some...
Or if you put something that said, click here for more information about umbrellas.
Yeah, exactly. Yeah.
So somebody, because otherwise somebody wouldn't know that they have an interactive picture.
Exactly. Unless they just happen to see the mouse change and be like, well, why'd that change? And yeah, that's...
Most of us are too stupid to notice that.
Yeah, and that's how people have taken advantage of that nefariously, which kind of ended up with image maps not being highly promoted. Like if you go to the W3 school site, basically it has one sentence about it, no examples or anything. So even the standards board is just kind of like, yeah, image maps exist. Moving on to something else.
Okay, so you're on the naughty list for them now, right?
Yeah, kind of. But they can be incredibly useful if used properly. So, and because then, like here, the home page can be just a big, nice picture and have buttons embedded in it. Or for the little educational video games I write, it's a very, very easy way to get a controller there. Right? And just stick a picture of an Xbox controller on there. And then when somebody pulls it up on a tablet or a phone, it looks like a controller they're familiar with to mess around with the little video game. So quick and easy for that. Different uses for it. Obviously, please use it responsibly. Don't use it to like hide things so that people wouldn't know that the image is clickable. Make sure people know you can click on the image. Like, oh yeah, like Joe just mentioned, when in that hover text say, click here for more information or something so that people know they can click in those spots. Otherwise, they're going to think it's just a picture. But it is something that can be useful. There's that. So that brought us up to about 2:15. So I guess now is probably a good time to take a break. And then afterwards, I have some other graphics things I want to look at. Graphics in a markup language. We'll talk about that after the break. And then a couple more tags that may prove useful for you at some point. So why don't we take 10 minutes? That'd be good for everybody.
Cool beans.
All right, so let's say 2:17, it's probably gonna roll over. So we'll meet back here at 2:28. I'm gonna go get a cup of coffee and I will see y'all in just a moment.